All right, in problem 9, we have the function f defined above. And so we're asked for what value of k is f continuous at x equals 2. So here we have a piecewise function. And so we essentially want to make it so that there's no point of discontinuity. Hence, that's what it means to be continuous, obviously. So the strategy is basically to make this expression equal to k when x equals 2. Now, if it's in this form right here, it'll be undefined when you plug in 2 because when you plug in 2, you're going to be divided by 0. So what you can do is factor that out. And essentially, you'll just have 2x plus 1 left, and we'll set that equal to k. And we really just want it to be equal to k when x is 2. When x is 2, we just plug 2 into here. So you just get 4 plus 1 is k. So then k is just 5. And so our answer is just E. Or number 10. What is the region in the first quadrant bounded by the graph of y equals either x over 2 and 1 x plus 2? Okay, so here let's just draw a picture and we really just have to integrate. But we want to know what exactly we're integrating so we can know our upper and lower bounds. And I mean that for that line to look like that. The pencil exploded. So we're integrating this graph, which you should know will be an exponential going like this. And it's going up until the line x equals 2. And first quadrant, so we're going to integrate from 0 to 2. We don't actually need to know this value, but it's simply just plug in 0. It's simply just e to the 0 or e to the 1, 0, 1. So we want to just integrate this. We want to integrate from 0 to 2 of e to the x over 2 dx. So let's find essentially the antiderivative of this. If you can't recall what it is like off the top of your head, so if you haven't done this enough, we'll just use u substitution. We'll make u equal to x over 2. That means du will be 1/2 x dx. Oh, no, 1/2 just dx. And we don't have 1/2 dx in our problem. We just have dx, so we're going to have 2 du equals dx. And so then our integral then becomes 2 e to the u du. Remember, du is x over 2, and 2 du is a dx. Now the endpoints here change because now they're in terms of u. So we look for what the u value is, or u values are when x equals 0, and when x equals 2. And let's write them in terms of u. So when x equals 0, u will just be 0 over 2, so u will just be 0 as well. When x equals 2, u will be 2 over 2, or u will just be 1. So the endpoints go from 0 to 1. If you change endpoints in terms of u, you won't have to revert back to the x variable, which I think saves time. So now we just integrate this. The 2 just factors out, so really just integrating this, which is a very, or should be a very simple integral, because the integral of e to the u is just e to the u, just like because the derivative of e to the u is just e to the u. So all we have is 2 e to the u from 0 to 1, which will again just be 2 times e to the 1 minus e to the 0, which is just 2 times e minus e to the 0 is just 1. So 2e minus 2. I think that's what the answer is going to be written in. And then, yes, our answer is going to be A. If f is the function defined by f of x is the square root of the absolute value of x minus 2 for all x, which of the following statements is true? F is continuous but not differential at x equals 2. Okay, it's continuous, let's see. So we have the square root function, and we're taking the square root of essentially where x of the absolute value of x minus 2 So what does this even mean? That's the value of x is minus 2. So let's just, let me just draw a sketch. And this is just, remember, absolute value graph of V shape, and has basically a vertex of 2, 0. Now, what does that mean? Is that you're always taking, this is always going to be positive. You're always taking the square root of a positive number. Positive number will be 0 or greater. So this will be continuous always, because again, you're not now I'm saying this doesn't look necessarily like this, but you're taking the square root of positive numbers. So from zero and up, you know? And it's always going to be continuous because you can take the square root of any positive number. It will be continuous. But it's not going to be differentiable because we got a sharp point here. The left hand slope is not equal to the right hand slope. I call a sharp point, or maybe it's called a cusp or a peak. But the two slopes from both sides don't equal each other. So then it's not differentiable because both derivatives don't equal each other as we approach 2. So it's not differentiable at x equals 2. So actually our answer is just A, straight up. You don't have to waste time with the other ones. All right, using substitution, u equals square root of x. We're going to integrate the integral from 1 to 4 of e to the square root of x over square root of x dx. This is equal to which of the following? Oh, so we don't have to actually technically go all the way and solve it or evaluate it. We just have to find which one it matches up. So use substitution. If you use the square root of x, let's just write that again here. Remember, square root of x is just u to the 1/2, same, or x to the 1/2 power. So du will be 1/2 x to the negative 1/2, which is just 1 over 2x to the 1/2, or 1 over 2 square root of x. I went through it that way so you can see exactly what it matches up, because then you can see that what we have in this integral is e to the u on top, and our du, we almost have it here. We have the 1 over square root of x, 1 over the square root of x. I forgot to put the dx here, du. But we got to take care of that 2, so we're going to multiply both sides by 2. So we have 2 du equals 1 over the square root of x. I don't know why I'm writing so big. 1 over the square root of x dx. So what we have is this. So we're going to have this times 2 du in our integral. That takes care of that and that. Now the endpoints, these are in terms of x. That's when x is 1 and x is 4. So we want to find what these are in terms of u. So we got to change these into u variables. If x equals 1, use the square root of x, or use the square root of 1. Use the square root of 1, that means u is 1 when x is 1, so they're both coincidentally the same. When x is 4, use the square root of 4, or u will be 2. So then we're going to integrate, we're going to go from 1 to 2. So this will be our answer, and this will match this one. Remember, we can take out the 2, we can put the 2 in front, outside the integral. That's all good. Moving right along. All right, good one. Function f is defined by f of x, another piecewise, where x is 2 when x is less than or equal to, when x is 2, or f of x is 2 when x is less than 3. F of x is equal to x minus 1 when x is greater than or equal to 3. What's the value of the integral of f of x from 1 to 5? Okay, so let's first draw a picture or sketch of what this looks like so I can help you better understand what's going on here. So it's a simple piecewise function, so don't be intimidated by it. So remember, again, these problems can be done in 2 minutes or less if you understand them. So don't be afraid if you want to draw a sketch or do some extra work to clear up what's going on. So f of x equals 2 and x is less than 3. So let me make a mark of 3 here. So this is basically saying it's a horizontal line. Basically, it's the line y equals 2 all the way to 3. There's an open circle there. Now, at 3, it becomes the equation x minus 1. So, remember, we draw it's it's just a linear function. Just slope 1 minus -1. So we just climb up 1 over 1. But let's see what it is when it's 3. If you plug in 3 into here, f of 3 is just 3 minus 1 or 2. So this point is there because that point is at 3, 2. And then so we just have a function that has a slope of 1. It's going up 1 over 1. So very simple, basic linear equation. And we're going to 5. Let's make that 5. So we're at this point, 5. We plug 5 into here. 5 minus 1, so it goes to the point 5, 4. That point will be 5, 4. This point will be 0, 2. We want to integrate from 1 to 5, though. So actually, let's go 1 to 5. We want to essentially just find the area of this whole thing. Now, you don't have to use a fancy integration formula because you can break this area by using geometry. You can break it into this rectangle, and this rectangle, and then this triangle. You find the area of each of those, add them together, and you're good. This happens to be a perfect square. So 2 by 2, height of 2, width of 2, area of 2. This also happens to be a perfect square. 3 to 5 is 2, height is 2 again. Or sorry, 2 by 2. So back to the 2 by 2. A 2 by 2 square and a 2 by 2 square, even though it's not down to scale. So this has an area of 4. This is also going to be a square, 2 by 2. I know it doesn't look like it, but it'll still have an area of 4, the same size as this one. 4, 4. And then here we have a triangle with a base of 2 and a height of 2, but we're just going to have half of that square. So this will be 1/2 times 2 times 2, or just 2. So our total area will be 4 plus 4 plus 2. That'll be our integral. So our integral will be 10. Our answer will be D. And 14. If f of x equals the square root of x minus 2 and g of x equals 3x minus 2, then the derivative of f of g of x at x equals 3 is. Okay, so this is going to be some chain reactions. We got to actually know our stuff. So let's find the derivative of this. If my pen will cooperate, my pencil will cooperate. Did I still got some more? All right, good. I'm good. All right, so let's find the general derivative of this. This is chain rule. So the derivative of this will be f prime of g of x times the derivative of the inside, so times g of x times g prime of x. Now, if f of x will be, the square root of x minus the square root of x squared minus 4, and g of x will be 3x minus 2. If you have f of g of x, what you got to do is you got to put this 3x minus 2 in place of that x. So f of g of x actually becomes the square root, instead of, remember, that x squared will be this whole thing squared. It'll be 3x minus 2 squared. So let's first evaluate this, or simplify this. So 3x minus 2 squared, that'll be 9x squared. minus 6x minus 6x and minus 12x plus 4. This pencil's not cooperating with me. I might have to switch a pen for the last part of this. I want to, but I have no choice. Oh, here, found it. All right, f of g of x will be the square root of 9x squared minus 12x. These squares will cancel. If you're like first confused, like how did I get that? Remember, 3x minus 2 all to the second power is 3x minus 2 times 3x minus 2. Make sure you know this is just basic algebra. You probably learned by the FOIL method. I just did it all, quickly in my head, so we don't spend too much time with that. All right, so if we want to find the derivative of this, now this is the same as 9x squared minus 12x all to the 1/2 power. So we want to find the derivative f prime of g of x. Remember, we have to do f prime of g of x times g prime of x. So we just find the derivative of this, essentially. So using the power rule, 1/2 times 9x squared minus 12x, the negative 1/2 times the derivative of the inside. The derivative of the inside will be 18x minus 12. And this is just essentially equal to 18x minus 12 over 2 times the square root of 9x squared minus 12x. Now you can go further and factor some stuff out, but let's just leave it like this for now. But now all we just essentially are going to do is then find what the derivative is when you plug in 3. So f prime of g of 3 will be equal to 18 times 3 minus 12 over 2 times the square root of 9 times 9, or 9 times 3 squared. 9 times 9 minus 12 times 3. $18.54 minus 12, so 52, 42 over 2 times the square root of 81 minus 36. 81 minus 36 will be 45. I made a mistake there, but then did not. That'll be back in 21, 1. So 21 over square root of 45, you can break 45 as, remember, 9 times 5. So 3 times square root of 5 here. So they're going crazy with the rationalization. So then we go to the next line here. So 21, remember the square root of 9 times the square root of 5. Square root of 9 is 3 times the square root of 5. And we rationalize. They looks like their form isn't to have it in the rational form. Or no, actually, no, they don't have it. They have this. That looks like they have the, this is to them. This just becomes 7 over root 5. Oops. And let me break this out over here. 21 over the square root of 9 times the square root of 5. If you're wondering how I got that. 7 over root 5. And so then our answer will be A. Now, this is probably longer than the way what they wanted you to do, because they probably wanted you to do the inverse function technique. But I don't like doing it that way because it's sometimes economics can be, you may not memorize it correctly, or it just sometimes it can actually drive you crazy if you mess something up. So I actually don't recommend my students memorizing it because it can, just because you could have that slip up or something. So I mean, if you have if you're confident with it and have perfect memory, then use it. But I honestly think it's not easier. It's just quicker, and it really only saves you like 2 minutes.